Good evening, everyone. Welcome to the April meeting of the New South Wales Branch Society, a branch of the Statistical Society of Australia. We're a bit late for our April meeting because we had such a great speaker to bring to you all the way from Houston, Texas, y'all. Hadley Wickham is, well, I asked him if he wanted me to read out through his bio, and he said read as little as possible. So that's it. Hadley Wickham. So, can you all hear me okay? So, today I'm going to talk about tidy data, and not just tidy data, but kind of like tidy data. So, I'm going to talk a little bit about some recent work I've been doing with tidyr, and then I'm going to show you a bunch of tidy data sets that will hopefully make you feel uncomfortable in various ways. So, use that to kind of inspire some thoughts about maybe what are some things that we need more than just. But before we get into that, I have a challenge for you all, and that is, what is tidy data? So there are three important principles behind tidy data. I want you to try and brainstorm them with your neighbor. You have 1 minute going out. Okay, time's up. So, who wants to suggest one of the three principles? Tidy data.
One observation per row.
Right, you have one observation per row. What goes in the columns?
Variables.
Variable. So hopefully each variable is a column, each column is a variable. And the last principle is that every cell contains a single value. So you can give yourself a round of applause if you got those correct. So today I want to talk about kind of two new tools. Like this is tidy data, right? But basically you will never ever get a data set in this form, or well, you will very occasionally, but it's called a celebration. So I want to talk about two new tools for helping get untidy data sets into this tidy form. And then I'm going to show you these data sets that are technically tidy, but will hopefully make you feel uncomfortable in various ways. So today I want to kind of focus on these two first principles of tidy data, because they tend to kind of go along together. Like if you fix one, if you make sure every variable is in a column, typically you'll kind of get the second one for free, or you generally kind of need to use the same. So the last one, where each cell is one value, this is, I think, comes up most commonly when you are dealing with sort of web data like JSON and XML, where you end up with these horrendously nested lists and lists and lists and lists. And you need tools to kind of unpack those or rectangle those in various ways. Those are really important tools too, but not what I'm going to talk about. So there are these two main tools. I'm going to show you a couple of animations. I'm not very good at making animations, but hopefully they will kind of give you a sense of what the kind of key operations are. So there's two main operations. In the first one, you have a data set that is kind of short and wide, and you want to make it longer and skinny. So you do that kind of by dividing the data up into groups, and then kind of duplicating the column names everywhere. Then you sort of rotate them around and join everything back together. So in this scenario, we've gone from a data set that's wide and short to one that is longer and skinnier. And then, of course, we can go in the opposite direction. We can go take something that is narrow and long, and we can make it wider by basically doing the opposite approach by kind of rotating in the opposite direction. Now, the thing that happens in this case, we're going to create some new variables, and you'll notice that not all of the original data sets have all of the new variables. I think this is one of the things that's really fascinating to me about different representations of the same data, is what happens with missing values. Like when we go back to this form, the fact that we don't have any information about the number of eggs that Harry has, that is implicitly missing in this form. Right? That is simply a record, a row that is absent, not present. There's not an explicit missing value there. But when we change forms, now we need to introduce some explicit missing value because of this structure. And I think sometimes you get data sets which have missing values that aren't really missing, they're imposed by the way that the data set is structured. Sometimes you have data sets that have data that is really important that is simply like not present, and it's really useful to make those explicitly missing. And we can just kind of finish that off to get back again to a rectangular data set. And these various transformations have many different names. So if you have used spreadsheets before, you probably use pivot tables. Spreadsheets don't kind of talk about the opposite so much of unpivoting. Databases call these fold and unfold. The reshape package, I call them melt and cast, and the reshape 2 package, I call them melt and decast, and the tidyr package, I call them gather and spread. And unfortunately, people had a lot of problems remembering gather and spread. So this first tweet was from 2015, and we've got another one for 2016, and another one from 2016, another one in 2017, and another one in 2018, and another one in 2018, and still more to this. So spread and gather are kind of strange to me because at the time I wrote them, they made perfect sense to me. And it was very obvious like which direction was gathering and which direction was spreading. But I once had a conversation with Jenny Bryan about who metaphors for them. And I don't even remember what the conversation was. All I remember was it involved like a tube of toothpaste, and it basically broke the connection I had, so I could never remember which direction. So I think it's a really bad sign, even the author of the functions can't remember which ones to use. And so what I want to talk about today is 2 new functions called pivot longer and pivot wider, which hopefully is obvious that pivot longer makes your data set longer, and pivot wider makes your data set wider. Sometimes it amazes me, like, how long it takes me to come up with such obvious things. But here we are. And the kind of neat thing about these variable names is that they're slightly data-driven. So I did a little survey on Twitter, a convenient sample of my Twitter followers. So no great claim that this is a wonderful survey. But I showed people 2 different forms of the data and asked them what kind of, I said, like, how would you describe table A compared to table B? And you'll see most people selected, the vast majority selected wider and longer for those 2 forms. So it's kind of interesting just to verify that that was my sense, that longer and wider. A few people on my team have suggested maybe taller as a better name than longer, but pretty clear signal here from this data that longer and wider seem to be names that are pretty good for most people. So you can, if you want to,
take a look at this analysis. The data's all up in GitHub, and you can see my R code. I just want to show you this because I also, I think, if I remember correctly, also included some of the write-in answers. Some of them are pretty reasonable, and some of them are pretty ridiculous. So I think people, I don't know, people suggest you should never have write-in questions on surveys for good reason. Ruby, yeah. So a lot of very creative suggestions that did not make the cut, but I can hold them in reserve if I decide.
But to be clear, spread and gather are not going away. They will just kind of live on as is forever. And the next version of tidyr, the development version of tidyr, has these new pivot longer and pivot wider functions. And there's some evidence to suggest that people can remember these new forms through tweets. So now I have two positive tweets, and my colleague Mina messaged me this on Slack. That she's forgotten exactly how it works, but could look it up much faster than any interaction in the past. So what I want to do next is kind of talk a little bit more about this pivoting. I'm going to show you some code and just talk through how these two new functions work. Okay, so I'm going to start with this pretty simple data set. And let me just tweak things around a little bit. Can everyone read this code okay in the back? Okay, awesome. So this is a data set. It's a survey that surveyed people, asked them a bunch of questions, but this table summarizes their religion and their income, and the cells in the table are the number of people within each category. So I think this kind of perfectly illustrates the problem with untidy data. Here we've got three variables, religion, income, and count, and those variables are stored in three different ways. We've got one variable, the religion, which is in the columns. We've got one variable that's spread across the column names, and then we've got one variable that lives in the cell values. And you can imagine, this is the basic reason that working with untidy data is so painful, because depending on how the variable is stored, you're going to need to use a different tool to work with that variable. If you imagine filtering to pick a religion versus an income, or to find all the cells that had more than 100 people, you're going to need to use very different techniques for each of those operations. So what we want to do is, this data set is too wide. We want to make it longer. What are we going to transform? That's the first argument. We are going to transform every column except religion. What should the names of the variables go to in the new data set? They're going to become a new variable called income. What should the values and the cells go to? They're going to become a new column called count. And so if we run that, we now get this nice tidy data set where we've got three variables. Each variable is stored in a column. Okay, slightly more complicated example. This is the Billboard Top 100 for the year 2000. Again, you can see this is pretty untidy. We've got artist, track, and date entered. Those are all variables already. Those are variables in columns. We also have the rank for each week from week 1 all the way up to week 76. So again, we want to tidy this. We want to make it longer. What variables are we going to select? We want to modify all of the variables that start with WK, short for week. What should the names of that variable go to? It's going to become a new column called week. What should the values in the cells become? It should become a new column called rank. The other point of confusion with gather and spread was also when do you put the name of a variable in quotes and when do you leave it as is? It's much clearer in pivot longer and pivot wider. When the variable exists, you refer to it without quotes. When you are creating a new variable, you put the variable name in quotes. So if we do that, and again, we get a nice
tidy data set. This is another case. This is a case, however, where we have these kind of missing values that, so this is a song that only ended the chart for 7 weeks. But because of the structure of the data set, because we've got all those columns, it has to be filled out with missing values for all of those 76 weeks. So it's not in those 76 weeks its rank is unknown, it's that it fell out of the top 100, and really these values just shouldn't exist. So what we can do here is we can say values drop NA true, and then that will remove all of the NAs. So in the we're saying those values are structural NAs. We don't care about them. We want to get rid of them. There's a few other little helpful features that you can do now. You can add so you can say all the names like start with a prefix, and that just allows you to kind of strip that WK prefix off to get a nice week variable that is now integer, which is going to make your life much easier to start plotting this. Okay, makes sense so far? I'll take that as wild assent. Okay, more challenging example. So this data is about World Health. This is data collected by the World Health Organization about tuberculosis. So we have the country recorded in 3 different ways. So we've got it as a name, we've got it as the ISO 2-letter abbreviation and the ISO 3-letter abbreviation. We've got the year, and then we have a bunch of columns with some fairly rich structure. Right, so all of these columns start with new, because these are about new cases, but that's basically kind of redundant because every single column starts with this prefix. Then we have a 2 or a 3-letter. Oh, you'll notice here, of course, like there's some of those variables, of course, doesn't start with new underscore, they just start with new. Right, this is when you just start believing that the person who created the data is just messing with you at this point. But so we've got new, and then we've got some 2 or 3-letter abbreviation. This tells us how the case of tuberculosis was diagnosed. Then we have a 1-letter code, which is the gender, and then the age range. So if we are going to make this into a tidy data set, the names of the columns no longer are going to go into a single variable. We're going to put them into 3 variables: the diagnosis, the gender, and the age group. And so now we have to say, well, how do we do that? How do we break up that one string into 3 pieces? Well, you can use this pattern. We're going to supply a regular expression saying that it starts with new, optionally, followed by an underscore. Then we want to take all of the letters up to an underscore. That's going to be the diagnosis because it's in this parenthesis. And then we're going to take a single letter. That's going to become the gender. And then we'll take all of the other letters to the end, and that will become the age. So when we run that, we now get a nice tidy data set. We've taken those variable names and converted them into 3 variables: the diagnosis, the gender, and the age. Okay, so we're like getting more and more complicated each time. And now we're going to take another example. This one is from data table, because one of this feature is inspired by one of the really cool features the data table has for tidying data. So this is a slightly different problem. Now, I think the easiest way to describe this problem is we have multiple observations in each problem. We've got some data about families. We've got the date of birth of each child and then the gender of each child. And again, you can see we've got these structural missings here because it's probably not that we don't know the date of birth of child 2 and we don't know the gender of child 2. It's probably this family only had 1 child. So again, we've got the structural missing value here. It doesn't really represent an observation that was not performed. It represents something that just was not possible. So how do we fix this? Well, we're going to use the same basic idea. The columns now have to do we have to do two things again. The names of the columns are going to go into two variables, and one of those variables has this special name value. So rather than describing what values are in the cell, we can't do that, right? Because we've got both date of birth in some cells and gender in some other cells. We're going to say, figure out the gender based on a component of the column. This time, rather than supplying a pattern, I'm just using a separator. So the thing that comes before the underscore is the value. The thing that comes after the score is the child. Maybe calling it child ID would make it a little clearer. And again, we've got structural missing values, so we're going to drop them. And again, this gives us a nice, tidy data set in one step. Doing this with spread and gather required like 3 steps. I think at gathering, you do something like mutate stuff and then you have to spread it back out again, which was annoying and I think caused problems with losing the various types of variables because you had to cram them all together in one column. So I've showed you a focused here mostly on pivot longer because it tends to be the data sets you find in the wild tend to be too wide rather than too long. And that is generally because, not because people hate data scientists, it is because generally when people are writing data out, they're not thinking about how to make it easier for other people to read in. They're thinking about how can I look at this and make the comparisons that I most care about most. But I did manage to find, of course, in the wild, I should mention, none of these data sets are like made up. Well, I guess this one's made up. But none of the other data sets are made up. Like I simply do not have the creativity to come up with the types of data sets that you actually find in the wild. But now I want to show you one other data set which does require a couple of steps. Oops, and I just pressed the wrong keyboard shortcut. This is some world data from the World Bank. We've got country, that's easy. We've got indicator, that's a little harder to know what that is yet. And then we have a bunch of columns, which you can probably guess are actually years. So I'm going to start by like making it longer. I'm going to pick all of the columns from 2000 to 2017. The names of those columns are going to become a new year variable. I don't know what the values should be yet, so I'm just going to call it value. And now I get a tidyr data set, but we also have this indicator. I can now count it just to see what's going on there. We've kind of got 4 values there. Any guesses as to what those cryptic abbreviations might mean? Any World Bank data experts there? Pop, probably a good guess, population. Grow, maybe growth. TOTL, total. And then I think the only thing you might guess is urban, which is a shorthand for urban population. We've actually got like we've got 4 variables here, right? The total population, the total population growth, the urban population, and the urban population growth. So this is a case where we have a data set that is too long and we need to make it wider. So now we're going to use pivot wider. Pivot wider is the opposite of pivot longer. So instead of pivots, instead of names to, you have names from. What variable, what existing column should the names of the variables come from? And then what column should the values in the cells come from? And so when we do that, we now get a nice tidy data set. The variable names aren't the best still, you could fix it up later. But we basically have a nice tidy data set where each column is a variable, each variable is a column. And I should mention that if you want to see any of those examples or many, many more, they are available in a vignette in tidyr, and the pivot vignette, which goes through many, all of those examples and many, many, many more. One of the things that kind of struck me as I was working on these functions and thinking about how to document them. It made me like reread the documentation for gather and spread. And I just wonder like how did anyone figure out how to use gather and spread? The documentation, I mean, it's like it's okay, but there's just nowhere near enough of it and nowhere near enough examples. So now there's this vignette which hopefully covers a very wide range of situations which you can use to model your data type. So those are the new pivot longer and pivot wider functions that in the development version of tidyr, if you install from GitHub, you can try out now. It'll probably be in France in a couple of months. What I wanted to finish up with is an attempt to make you uncomfortable by showing you some tidy data sets that at least make me feel a little uncomfortable, that leave me with some kind of questions about whether this is the right way to store these. I'm going to show you 3 data sets. They're all tidy because they all have variables in the columns. Each row is an observation, each cell is a single value. But I think there's something a little wrong with each of them. In this work is very much inspired by Codd's third normal form. How many of you have heard of Codd's third normal form? Okay, how many of you think you understand? So this is the definition of Codd's third normal form from Wikipedia. It's actually really annoying on Wikipedia because Codd's third normal form is Codd's second normal form plus one thing. Second normal form is first normal form plus one thing. So I could stitch this together across multiple pages. But just take a read of these. I think these kind of illustrate like the worst possible type of jargon, which is jargon which takes ordinary words and infuses them with special meaning. Because I think if you read these, you understand each word individually. But when you combine them together, like they basically mean nothing. Right? Like you know what's no. And you maybe don't know what what prime numbers, like non-prime, so maybe like composite numbers. You know what attributes is. Transitively dependent, that's a little bit more technical, but you've got some yes and then. So what I'm going to attempt to do is kind of explain to you Codd's third normal form in a way that at least I can understand, and hopefully you can understand as well. So I'm going to show you 3 examples, 3 data sets. These are tidy, that each violate Codd's third normal form in one way, and hopefully when you look at them and think about them, you will feel mildly uncomfortable. So the first data set is a data set that is built into R. It is called the DNA data set, and it is basically a data set to do with calibrating a laboratory test where we've fixed concentrations and we've measured the optical density and we've repeated that multiple times so we can build up this kind of curve. So in the future, we can measure the optical density, go back and guess at what the concentration is. So I want you to take a look at this data set, discuss it with your neighbor. What makes you feel uncomfortable about this data set? You've got 1 minute starting now. Okay, time's up. So let's do a quick show of hands who felt some degree of unease with the data set. Okay, does anyone want to say what makes them feel uneasy about this data set? Yep. There's no way of there's no combination of variables
that uniquely identifies each observation. You have kind of no way, you can see there's like some replicates here, right? We've repeated each measurement twice, but you've got no way to kind of refer to one of those except by using the position, which is not great. So we can fix that by adding another column, which is just measures, which just records whether it's the first replicate or the second replicate. Now, you may kind of wonder whether that's, I don't know, just like, what's the point of that? I think one of the things that I think there's reasonable evidence for is like whenever you're doing a lab experiment, recording the information like this is really, really important. And if you're doing an experiment with multiple people, recording the person who did each experiment and then looking at that in your analysis will often turn out to be like the biggest explanatory factor. So I think it's really good to make sure you're thinking about that and controlling. I've also drawn a line here to kind of separate these variables into two groups. We've got variables whose main purpose is to identify the observation, and then we have variables that we've actually measured. Right, so in this case, if you listen to my explanation, you'll know that concentration is like fixed by design, and if you didn't pay attention, you'll at least be pretty suspicious that you've got two pairs of identical values. So these are things that you can basically write down. These are your experimental design. You can write this down in advance of doing the experiment, whereas this column, the density, that is what you're actually measuring in the experiment. Okay, another data set. This is the Billboard Top 100. I want you to look at this and think about what makes you feel uncomfortable, apart from Baby Don't Cry being the top 100, or the hardest part of breaking up, I think. I want you to look at this data set. Again, talk it over with your neighbor. What makes you feel uncomfortable about this data set? You have 1 minute starting now. Okay, time's up. Let's do another quick show of hands who it feels some vague sense of unease. Okay, I'm going to make one change to the data set. Toggle back and forth. Okay, see what the difference is. Does this data set just make you feel more uncomfortable? So what's concerning about this data set is that we have facts, the same fact recorded multiple times, right? The fact, who is the artist of Baby Don't Cry? Is it 2 facts or is it 3 facts? Obviously, we can use our knowledge to guess. But whenever you have like a fact repeated multiple times in your data set, that gives it the opportunities for inconsistencies to arise. And I think you really want to resolve those before you do any other analysis. I think there's also kind of a statistical question here, like how many pieces of information do we actually have about the artist? We've repeated it in every column multiple times, but we don't really have, these aren't unique observations. It's the same piece of data repeated again and again. So how do we fix that? Well, I think it turns out we don't actually have one data frame here, we actually have 2 data frames. We have one data frame that records facts about a song, like who the artist was, when it ended the top 100, and then we have another data set for each song for each week, what was its rank. Now, I'm not sure sure whether you would actually want to, like, whether this form is actually easy for analysis or not. But I think this is a form that's really important to go through so you can make sure that you do not have inconsistencies in your data. Oh yes, so there's also a problem here. I have used the song name as the identifier for the song, which works fine for like a single year of data, because generally one band will not copy the song name from another band in that year. That would not work over a longer period of time. And you either have to identify it by maybe both the artist and the track name, or come up with some kind of made up unique identifier. We've got one last example, which comes from a Excel spreadsheet produced by the Census Bureau in the US. And my experience is that Excel spreadsheets produced by government agencies invariably are like, they trend towards like maximally untidy. So this spreadsheet, it basically records for each year, for each month, how many construction permits were applied for. And if you kind of look at this spreadsheet, it's quite amazing the way that different ways that variables are recorded. Each sheet has the seasonally adjusted rate in one table and not seasonally adjusted in another, and then each sheet in the spreadsheet is a different variable, basically stepping along from permitting to authorized to started to under construction. But I'm not going to show you the glory of that data set. I'm just going to extract a little bit. I'm going to do a little bit of tidying up. So we've got a tidy data set now, where each column is a variable, each variable is a column. Again, take a minute, look at this data set. What makes you feel uncomfortable? Okay, time's up. So who feels uncomfortable with this data set? Yes, we're the most uncomfortable. And why do you feel uncomfortable? Yeah, so either the region is missing or the units are missing. We don't actually have any information about the combination of units, number of units, and region. We don't really have one table here. We have two separate tables. One which gives us information about the number of units in each region, number of units made in each region, and another table which tells us about the size of those units, whether it's a single family dwelling, a 2 to 4 family dwelling, or an apartment building. So I've shown you 3 data sets that hopefully made you slightly uncomfortable, or just my presentation style made you uncomfortable. But I think it's important to think like these are all tidy data sets, but they're not like perfect. They had some like problems with them that are kind of revealed by like Hod's third normal form. And so what I'm trying to do is take those ideas of Hod's third normal form and explain them in a way that like most people can just kind of get without too much of this specific database jargon about keys and so I think it's really useful to think about variables falling into 2 classes. a variable is either a key, either i.e. it serves to identify an observation, or it is a measurement, i.e. something that you actually record on the observational unit. And so if you do that, we can start to kind of attempt to refactor Cobb's third normal form. Unfortunately, unappealingly, my attempt at third normal form has only ended up with 2 principles, which makes me concerned that I missed something, but basically, you want to ensure that every observation is uniquely identified by a set of keys. That is what defines the key variables, is what defines your observational unit. And then everything you measure should be a property of the observational unit defined by all of the keys, not by some of them. So if we kind of go back to our various examples, let's flick all the way back. So DNAs, we didn't have any key that uniquely, we didn't have any combination of variables that uniquely identified our observational unit. And that makes defining what an observational unit is here, and I think it makes it hard to be precise if we start to model this using some kind of hierarchical model. It makes it more challenging to be precise about exactly what our model is. In this case, we have some data that doesn't depend. Well, we've got to, like, what are our keys here? Are our keys our keys track in week? If they are, then artist doesn't really match, doesn't belong to those combination keys. And again, in this case, we have a slightly different problem. We have 4 keys, but none of our measurements use all 4 of those keys, which are basically the 3 properties of Cobb's third normal form. So this is still a work in progress. This is challenging, of course, because this definition works because I have just introduced some new jargon. Hopefully, it is jargon that is a little bit more intuitive, I think, to statisticians and data scientists. I think one of the things that I found appealing is this being able to be precise about what an observational unit is. That is something that really kind of puzzled me in the original tidy data paper. Is something that was very difficult to define, but now we can say an observational unit is the unit defined by the keys. It's a little bit circular because one of the keys I want to unit, but I think there's something interesting there. So as I'm going to continue to refine those definitions, there's a few other things I've been working on in tidyr as well. And I mentioned earlier that we also have this problem of what happens when you have multiple values in a single cell. And there's a few ways that it can happen. One way that it can happen is instead of having like a single number in a cell, you can actually have a data frame in a cell. And so we have these nest and unnest, which have been in tidyr for a while, which make it easy to go between these 2 forms. This form, I think, actually turns out to be really useful when you're doing various types of modeling, because now you can have a data frame with 1 column, for example, that has all of your training data sets. You have 1 column that has all the models corresponding to those training data sets. You have another column for your test data sets. You have another column for your predictions. And you keep all of those things together in a data frame so that you always operate on them. There are now 2 new pieces to this. So unnest can be kind of broken down into chopping and hacking. So if you unchop this, you get what I call a packed data frame. A packed data frame is a data frame where one of the columns is a data frame. And this is something that you've been able to do in R for a very long time. No one has done it by and large. And when I kind of discovered you could do this, like I scratched my head for a while, like this certainly seems cool to me, but lots of things seem cool to me but have limited practical application. And the thing that really sold me on this is a useful intermediate form. It's like when you draw it out, it just looks like a table where you've got like a merged cell in the column headers. And judging by like random Excel spreadsheets you see on the internet, people love this way of structuring. So even if this kind of exists just as a way of modeling data in the wild, you never actually use it for analysis, I think it's important to think about this, and then so we can decompose nesting into these two simple operations of chopping and unchopping. The other way that you can have complex data in multiple values in a single cell in R is you could just have a vector. And the problem with a vector is you don't know whether like the vector should be kind of go this way or does it go this way. Like a vector doesn't have it's not obviously a row or a column vector in R, and that implies that you really need not just unnest, but you need to go to unnest directionally, either making a wider data frame or making a longer. So my intuition is if you work with JSON a bunch and you struggle to take these very deeply nested trees and turn them into nice rectangles that you can work with, my intuition is that unnest wider and unnest longer should make that much, much easier. There's also another new verb that I've been working on very recently called hoist, which allows you to kind of reach in at any length inside a deeply nested list and like pull it out to be a top level variable. Those functions are available in the development version. Their documentation is so-so, and I am working on Vignette at the moment. So if you have like crazy JSON examples that seem really difficult to work with, in the very near future, I will be soliciting those on Twitter. So just to finish up, if you do want to learn more about these new pivoting functions, you can read the vignette that's included in the development version of tidyr. The code is it's surprisingly well tested. It's pretty well documented. I think if you are brave enough to install from GitHub, you are going to be, there's not like any crazy breaking, shouldn't be any crazy breaking changes in there. There certainly won't be for release. If you just want to try it out, spread and gather, remain the same. So you don't have to worry about breaking your old code, but pivot longer, pivot wider, I think should be much, much easier to use. And you should hopefully, the payoff for switching to the new code should be pretty high. Thank you.
Thank you, Hadley. Does anyone have any questions? Boris is going to walk around with the microphone.
So these could be, are they going to make their way into
In principle, yes. In practice, that depends on being able to like actually generate the SQL to do that. There's like an issue. There's already an issue on this for dbplyr. It's just a matter of figuring out. So SQL Server has a pivot function, but no other database does. So it's a matter of like figuring out how to generate all the SQL to actually make this work, which is totally possible. And I probably would do it one day. But I'm kind of hoping I should, where is this? Here we go. Yeah, let me just make this clear.
one more
yes, in fact, that is there in the current version. The version that just got released a couple of days ago. It's a little hacky, but it allows you to kind of, in here somewhere, yeah, there you go. All join functions gain a SQL on argument that allows the specification of arbitrary join predicates, which is basically what you're asking. Another question? We can just like play Pass the Parcel, and whoever the music stops, you have to ask a question. And well, we really are playing. Sorry about the
running.
Oh, currently pivot long and pivot long and pivot wide are really slow. They'll hopefully be resolved. They'll either be resolved before release or shortly after release. One of the reasons that they're slow is because they're designed to be very general, because they're built on top of this vectors package. So one of the other kind of problems in spreading data that could occur is if you're working with variable type like dates and factors and things. If you spread and gather them, you can end up kind of messing up the variables in various ways. And the idea of vectors is to try and solve that problem systematically in a way that we can use throughout the tidyverse. And tidyr has been kind of the first test bed. And so Lionel and my team has been working on like rewriting a bunch of vectors and C, so it's much faster. So it provides a performant as well as correct underlayer for packages like tidyr.
Thank you very much.
You had a question, if you want to pack it, pass diagonally north.
Thank you. Just looking at you wrestling with the nested data structures.
Yep.
There's quite a synergy between the nested data structures and stuff going on in the group by world. And even in the group by world, I believe you can have nested levels of. What do you see? Did you see a synergy of those two worlds coming together, or a synergy just perhaps in solving what you're doing with now?
Yeah, I have a picture somewhere. What did I call this? Yeah, so I've been thinking about this quite a lot, and for me, thinking about this involves like drawing a lot of pictures. And so I think in some ways, like in some ways, I think understanding that like the pivoting transformation is actually kind of easier when you think about the data being nested, because you can see kind of just like rotating this, and this is why it's called pivot, because it's very like when you get to this point, it's very much just like rotating things by 90 degrees. So like an earlier kind of an earlier version of this diagram had like slightly more arrows, and I was thinking of it as the grand unified theory of tidy data. Unfortunately, that kind of fell apart. But you can see this is kind of like my design process is a lot of like sketching out how things should work. Another really interesting connection is to joins, because you can also kind of think of a join in many ways as going through kind of a grouped form, and there's sort of connections to Cartesian products and stuff. So, I mean, basically there's like a bunch of really interesting connections there, I think, and I'll get sort of winnowed down when I start writing this up.
If you want a really good niche use case, it's looking at when do you normally want to be forming operations on that group subset level. And the classic one that I keep coming across time and time again is supermarket baskets. You've got the dollar value basket, you've got all the items in the basket. You almost always want that two-level hierarchy. And processing it in a standard database using third normal forms is horribly ineffective, and that's the data structures over.
Yeah, thank you.
I was wondering if you had any thought to using CUDA abstractions rather than developing your own primitives in C.
CUDA, just this thing, right? The type of problem we are solving in vectors, I do not think that would be helpful, basically. Maybe. It shouldn't be like the stuff we're doing vectors is more, I don't know, I don't think it needs anything quite as extreme as CUDA. It's just like standard C programming. Yeah, but then you have to worry about this I feel like CUDA across multiple platforms starts to get challenging, and then like getting it working on CRAN to go on Windows is challenging, I think, if I remember correctly.
Thank you very much for your talk. Your talk reminds me of S4 vector class before and after. I'm really familiar with that. That is where you can have two data frames and use a key variable in them. If you subset one, the other one's also subsetted. My question, well, I don't have a question, it's a comment. Would you like to implement that in relevant data and infiltrate your workflow? Because I found editors to be much better for plotting purposes and so on. Do you have any future plans in that direction?
Yeah, I don't think we have any future plans to create bioconductor packages, but we hope that bioconductor packages copy us, I guess. Basically. Yeah, I think a lot of these ideas like bioconductor explored using S4, which I have complicated feelings about. But it's sort of also unfortunate that these are like fundamental ideas that are not really related to biological data in any way. They really need to be in like CRAN packages, so you can use them whatever your domain is. Another.
Could you tell us a bit about your collaboration with Wes McKinney?
Yeah, so very recently, or I guess it's not that recently now, Wes McKinney founded Ursa Labs, which is kind of not quite sure what the word is. It's sort of hosted at our studio, so we kind of provide sort of administrative infrastructure. The idea of Ursa Labs, part of it is this idea, this Arrow project, which is a efficient way of storing columnar data in memory, with the kind of idea is like, let's figure out the best or a good way of storing data, and let's agree on that across programming languages so that you can use the same data living in the same place in memory, regardless of what programming language you use. And so the hope is through the Arrow project and other things that he's working on is that the actual like programming language you're using kind of becomes less important, and it becomes easier and easier to collaborate across, to do data science projects that cross multiple language boundaries. Because I think it's very clear, like when I talk to data science teams in industry, the vast majority of data science teams use both R and Python. It is pretty unusual to find teams that are exclusively R or exclusively Python. And so it's really important to kind of us at our studio to like facilitate that, to make sure that our users can seamlessly interact with Python users. And I think this is just really important. The other kind of, I think, trend is that generally, like, fast Python code is fast for the same reason that fast R code is fast, namely, like it's been written in C somewhere. And so if you're going to do that, like, we don't really need to have like a Python C implementation and an R C implementation. Let's have one C implementation and then build on top of that. That's kind of the idea that underlies Arrow, that underlies Stan, a Bayesian computation framework. That basic idea underlies TensorFlow, like separate out the specification of the task from the actual implementation, so that the language, you can use whatever high-level language optimized for humans you want, and then behind the scenes, the code is translated into something that's really optimized for computational performance. Where is the microphone? Okay, cool.
This is a bit of a long, thought-out question, which is very poorly formed. But thank you for our markdown, by the way. It's wonderful. And I've recently been, as maybe other people in the room have found, had to present tables in publication for preprints. And there's not, unlike ggplot2, there's not really a good way to manipulate table forms from an underlying data structure. But the verbs that you're using here. So this is what I was wondering.
Yeah, so I think what you're asking for is asking about is this GT package by Rich Ianon. So the goal of GT is short for grammar of tables, basically. So the idea of this package is you have your data in tidy form, and then you have some easy way of turning that into a table designed specifically for comparison and communication. It's a really nice, it's a really slick package. And Rich. Rich makes really awesome websites. I guess this is slightly better.
Thank you. Thanks, I think that was a really great talk. I'm wondering, as a relatively new user, gather spread, I think, for beginners is one of those sticking points where 99% of the time without it is wide, and it's almost too hard to bother to make it long in order to bother going into R and getting all the advantages that you might get. What else do you see as those other sticking points that prevent beginners from making large progress, and what is you doing maybe doing things similar to pivot wide and long to help beginners along?
That is a really interesting question. And what are the biggest sticking points? I can kind of, it's sort of easier for me to tell you the sticking points that we've already identified and fixed. One of those was like one of the sticking points we identified was it was really painful to get data out of Excel and into R. And obviously that Excel, for better or for worse, is where the majority of data lives in this world. So we've invested in that. So I think a lot of the things I think about is that very initial sticking point is like I have some data in like a program that I'm already happy with, and if I can't get in that into R, like what's the point? I think the other thing that I kind of think about and that we've been spending some time on lately is not necessarily the big things, but just lots of little small frictions. And I think that's particularly like inconsistencies between different functions. And so one of the things we've been thinking a lot about is how can we be more consistent, which is getting kind of harder and harder. Like now it's hard enough to be consistent within a package, but now we have like multiple packages in the tidyverse, and we want them to work together as seamlessly as possible, with the idea that if you've learned one function in one package, that makes learning another function in another package like a little bit easier. And I think what we've been doing there, what I've been doing, this is basically the next book that I am working on, is to try and kind of elucidate the principles by which we design functions, which is kind of sort of morally challenging because there's a lot of things that I can just point at and say like, that's wrong and you should do it this way, but I can't explain exactly why. And so the kind of the goal of this book is like force me to do that, to kind of explain like this is a anti-pattern, this is something you shouldn't do, and instead you should do this. With the kind of hope, that doesn't affect like a data scientist who's going to read this book. But the idea is that by making this explicit, we can be more consistent within the tidyverse, and then eventually, other people can read this and they can make their packages consistent with the tidyverse too. And the thing we've kind of like, or the thing I've kind of like contemplated is like maybe eventually we could have some kind of like tidyverse like stamp of approval where we'll like sort of badge your package as being tidyverse compatible, and then that means if someone's familiar with the tidyverse, they can just pick up your package and use it, and the idioms are familiar. But we can't do that until I can figure out, until I can actually say what does that mean? Like what is a tidy API? I've already written like, I don't know, yeah, I guess I've already written like 25 chapters. These are like not like chapters in advanced art, these are all going to be like 2 or 3 pages. But there's clearly like a lot of things that are in my head that I've never really gotten out onto the page before. The things that we spend a lot of time talking about like within my team at our studio, and hopefully we can like make this available to everyone. I don't know, I mean, my sense now is already like statistics is kind of a minor user of R, that it's just exploded in like so many other fields. You know, I think 10 or 20 years ago, like when you looked at the typical R user, they were like someone who had or was getting a PhD in statistics. That is, I think, definitely no longer the case. It's been used like very, very widely. And I think part of that is sort of related to this, like the distinction between statistics and data science, and that in some sense, in my opinion, the fact that data science exists is like a failure of statistics. Well, certainly like my vision of statistics is like, has always encompassed what we would now call data science. Is just sort of a shame that academic statistics departments, by and large, did not understand many of the problems that actually make data analysis hard in practice. So I don't know, I think that's kind of already happening. It's, I don't know, like statistics is not dead. Like it's really, it's really important, but it's just one small part. And to kind of come back to Jenny's point, like the statistics is not, you can't do statistics until you've got the data into R, tidied it correctly, you've done some visualizations to understand what model you need. It's like very much at the end of the pipeline. Yeah, that's sort of beyond my scope. I know like Kara Wu and Carl Broman wrote a nice article. I think the other thing that's really like thinking about how to reach out to people, like where they are today, they wrote this really nice article, Data Organization Spreadsheets, which is kind of like, how do you teach these ideas to people using spreadsheets? And I think that sort of activity is not something that is like rewarded traditionally in statistics, but this is like so freaking important.
This is an R Shiny question. Do you see R Shiny as a viable enterprise BI competitor to the likes of Tableau?
That's a interesting question, because I think the answer is kind of like yes and no. Like, I think the Tableau's strength is that it's designed to be used by MBAs. Are there any MBAs in the room? Hopefully not too many. Like it's designed to kind of help people who are not like deep technical experts in the data to try and like, you know, do some basic visualizations and analysis. Whereas Shiny, we tend to see it used more by like kind of specialist data science teams to create dashboards and tools that integrate, you know, complex modeling. They're bringing in data from multiple databases and integrating it and doing, you know, complicated stuff to it to create something that is then like pretty simple and can be shared with an MBA. So like yes and no. Like I think that by and large kind of complementary, because they're different, like they're targeted. Like Tableau is kind of primarily like self-service, whereas Shiny is more about like helping your data science team be as effective as possible, so they're not continually making a new report every time someone asks. They can kind of develop self-service apps, but it's a little bit more constrained, but that also means they can bring all of their kind of data science skills to the table in a way that's harder to do in Tableau.
Thank you very much for everyone coming out tonight. I'd like to thank Dr. Mitsuka for organizing this event. She's very, very crucial in making this happen. And of course, join me in thanking Hadley for this really interesting talk.